Okay, question number 2. Let us start the timer. Right. The graph shows the variation with time t of the velocity of the object. When the velocity time graph is given here. Remember, this is not going to be your projectile motion. Don't consider this as your projectile motion. What is the variation velocity time of the acceleration of the object? How is the acceleration of the object changing? There are 4 graphs given over here. Okay, so somewhere you need to understand the acceleration. First, let us understand like this. When I draw a tangent to the velocity time graph, I get the acceleration. Let me draw the easiest point at this point. You see what you get over here? Velocity is constant over time, so therefore your acceleration is equal to 0. Now here you see the velocity initially at this point is very high, then it becomes higher and higher with respect to time, but still the curve is going like this over here. Okay, so for example, if I consider this point, and if I consider this point over here, you see the angle made by, this is your theta 1 and this is your theta 2, for example. Theta 1 is smaller than theta 2. So which means that the velocity, the acceleration at this point, let us say this is a1 and this is a2, acceleration a1 is less than a2. So if I use this logic, then I can say the acceleration is reducing over here, right? In this whole path over here, the acceleration is reducing. Now, if I consider this path, we have already considered the peak over here. So if I consider this path over here, then you see at this point, if I take, this will be the tangent drawn like this, right? And this will be this is the straight line, the x-axis. So this is the angle. If I take somewhere over here, this is my x-axis and this is my tangent drawn over here. Look at these angles over here, because acceleration equal to tan theta, which is tangent. Okay, so therefore this is your theta 1 and this is your theta 2. So theta 1 is less than theta 2, which means what? So this tangent is more, this slope is more as compared to this slope. Which means what? Which means the acceleration here is lesser, acceleration here is larger. With respect to the symmetrical point over here, here the acceleration keeps on reducing, here the acceleration keeps on increasing. This is what we need to know. So towards it, which of these graphs will denote this one? If you look at the first one, acceleration keeps on reducing, then in the negative sense, acceleration keeps on increasing. So this is one of the most appropriate one. Let us look at the other ones also. Here you see acceleration is continuously increasing over here, right? So here it is reducing, becomes 0, it's increasing from negative, then becomes 0 and again it is increasing. This is not the way here, right? Okay, and then this is acceleration equal to constant, no acceleration equal to constant. So this is also not the case. So therefore A is the right option. Let us move on to the third